and good day, pre-algebra. Our first PO of the year. There's definitely a sense of excitement in the room. And it's going to talk about greatest common factor. You've done greatest common factor before. This is not a new objective, but how we use factors so heavily going forward, it is a PO. So if you don't know how to do them today, you're going to learn how to do them today, review how to do them today, and hopefully it's going to be set going forward. I do have kind of a standard method that I'm going to teach you, and then I've got a method that's actually new to me. I just learned about it over the summer, and so maybe it's new to you as well, but it might help kind of organize things a little bit. It's actually not the method that's listed on the page here because it's that new. I'm that excited about it. So, but first, what's a factor? Define a factor for me. Because if you're going to make a mistake in greatest common factor, it's going to be because you find what's actually called least common multiple, right? Those two get mixed up all the time. So, Kate, how would you define a factor? That's a fraction. So, similar sounding, but they both do start with an F. A factor. Jeffrey? Oh, you were talking, so I thought maybe. Oh, okay. Then let's not talk. Kate? Ah, you're getting closer. Yeah. A factor is a number that goes evenly into another number. Okay? A factor is a number that goes evenly into another number. I'll say it again. A number that goes evenly into another number. So, for example, if the given number is 12, right? What is a factor of 12? What is a number that goes evenly into 12? Kylie? 6. Okay? And I always kind of like to work with factors with like factor buddies. You know, what's the buddy with 6? What's the other part of that factor pair, Kylie? 2, right? And the reason why they're factor buddies is because 6 times 2 equals 12. But they are both factors. What's another pair of factors or just another factor of 12? Haley? 3 and 4 is another factor pair. They're factor buddies. 3 and 4 both go to 12 evenly. And there's one more. Lexi? 1 and 12. Okay? Good. And those will be the factors of 12. The only ones. How about a number like 84? 84. Lexi? 2 and 42. I have this OCD thing where I have to put the smaller number first. I realize I didn't here because it wasn't said as a factor pair. That's why I put 6. But if it's said as a factor pair, it's just, it's nothing. It's not you, it's me. We'll put it like that. Okay. Another factor pair of 84. Kate? 4 and 21. Cade? 84. Yes, someone's got to say that one. 1 and 84. Jack? 3 and 28. 2 others. And this is where greatest common factor can get tricky. Because if you're dealing with a number that's got a lot of factor pairs, or you're not as familiar with, then it can be difficult. I mean, the one that we need, and we'll see why later on, might be the one you miss. But yeah, Camille.
I don't know, maybe 7 and 12?
You are correct. 7 and 12. And one more factor pair.
6 and 14.
Well done. 6 and 14. Okay? And so, how you may have been taught greatest common factor in the past is kind of this method here. Okay? This is called the listing method because you literally just list out all of the factor pairs. It's nice because, it's pretty straightforward. Just list the factors, okay? That's the F here. List those factors. And then what do we do from here? Once the factors are listed, if I asked you for the greatest common factor of 12 and 84, once you have those factors listed, then what would you look for? What does the C in greatest common factor stand for? Common, right? You want those common factors. So you'd look and you'd say, okay, let's see. 6 is a common factor, and 2 is a common factor, 1's a common factor. Turns out they're all actually common factors. Every factor of 84 is also a factor of 12. But your next step, you would identify those common factors. Identify those common factors. Okay? And then the last step, that G, mirror, mirror on the wall, which is greatest of them all? The greatest common factor is 12. Okay? So we're going to find the greatest of those common factors. So if you just remember FCG, factors, common, greatest, that's one method that you can use, right? It's the backwards of GCF, but the steps are FCG. But what makes this method difficult, is that if Camille hadn't said 7 and 12, then we'd be at a loss because we wouldn't have that factor of 12 listed under 84. So the complication with the listing method is that you might forget a pair. And if it's the pair that you need, well, then you're going to get the wrong answer. Okay? Jeffrey. So the other method I'm going to show you today is more methodical. Okay? It helps eliminate this issue here. And we're going to scroll down for that. And I'm going to kind of do it over in the corner here, probably right here. So we'll still have space for 40 and 72 there. But what we're going to do, and I'm going to use multiple colors for this, it's this impressive, is I'm going to write the numbers 12 and 84. Okay? And then I'm going to kind of box them out here. Okay? Put a line right here too. And all we're going to look for is what is a common factor of 12 and 84. What can you divide both 12 and 84 by? What's the first number that pops into your head?
1.
Other than 1, because that doesn't change them. But you're right, but that doesn't help here. Kylie, 2. So if we divide, I'm going to point 2 out here. If we divide 12 by 2, what do we get? 6. So in my next row here, I'm going to put a 6. And then 84 divided by 2 is 42. Okay? I'm going to make another line. Now we've got 6 and 42. What can we divide both 6 and 42 by? Haley? 3. So I'm going to put a 3 out here. And 6 divided by 3 gives me 2. 42 divided by 3 gives me 14. Okay? 42 divided by 3 is 14. Is there any other number that I can divide both 2 and 14 by? Liam? 2 again. So I'm going to put a 2 out here. I'm going to put my next little row here. 2 divided by 2 is 1. 14 divided by 2 is 7. Okay? And I know that I'm done with my division now because there's no common factor between 1 and 7 other than 1, which if I divide by 1, nothing really changes. Okay? So that's how you know that you're finished. when there are no more common factors. Those numbers that we divided by, the 2, 3, and the 12, what do you notice about those? Anything stand out? What?
You multiply them together and they make 12.
2 times 3 times 2 equals 12, which is the answer that we got when we did this with 12 and 84 up above. Okay? So, what's my point here? The nice thing about this method is that you don't have to worry about missing a factor pair, because the way it's designed, you break it down kind of level by level, there's nothing to miss, right? You could do your math wrong, like when someone said 42 divided by 3 is 16. If you didn't check that and you wrote 16, obviously that would then throw you off. But as long as you're dividing correctly, you're not going to miss anything, okay? It's a little bit more organized. Lexi, wouldn't it be great if it did? It does. It does. It also works for every set of 3 numbers. Woo, thank goodness, right? So let's practice this with 40 and 72. Okay? 40 and 72. I'm going to write my numbers down here, 40 and 72. I'm going to kind of make my little grid here. Okay? If you didn't quite follow along the whole way through this first example here, we're going to do it again. Okay? So, who can tell me now once we got it set up, what's our first step? What are we looking for? Camille. Why 2? Why not 5? You are correct. It is 2. And the reason why is because 2 goes into both 40 and 72. We wouldn't want to start with 5 because 5 doesn't go into 72 evenly, right? We're looking for a factor of both of them, and that is 2. Okay? So now our next row here is going to be the quotient of 40 divided by 2, which is 20. And then 72 divided by 2, which is 36. Okay? Now what? Haley. Ooh, 4. Okay? 20 divided by 4 is 5. 36 divided by 4 is 9. So whatever number you're putting in the left, this first column here, you are dividing by that number with what you have in green there, what you have in the main chart. Are we done?
Yeah.
How do we know?
Because nothing less than a 5 in your
Because there's nothing else we can divide out of both 5 and 9. So what's our greatest common factor? 8, right? 2 times 4, not 2 plus 4, 2 times 4, and that's going to give us 8. Isn't that kind of nifty? You know? I mean, if you're really good with your multiplication tables and you're really good at number sense and you know factors, this probably would take more time than you just looking at the numbers thinking, okay, 40, 72, I know 8 goes into 40, okay, it's 8, right? But if you're not familiar with your multiplication tables and factors, this is a really nice way to set it up. I think so anyway. Okay? 12, 30, and 60. This time we have 3 of them. So we're going to make our chart here. What can we start with? What goes into 12, 30, and 60 evenly? Tony? 2 does. So we're going to divide 12 by 2. That gives us 6. We're going to divide 30 by 2. That gives us 15. And we're going to divide 60 by 2. That gives us 30. Okay? Question, Kate? Wyatt, question? Oh, question?
What we put in that blank spot under the 2?
We have nothing yet. What we're going to put there is a number that goes into 6, 15, and 30, but we're not quite there yet. Okay. Question? Next one? You already have for the last one too. So what number are we going to put in that spot underneath the 2? What number does go into 6, 15, and 30? 3 does. So we are going to divide 6 by 3 to get 2. We're going to divide 15 by 3 to get 5. And divide 30 by 3 to get 10. Are we done? Yes, because there's no number that goes into 2, 5, and 10. Yes.
How do you find the GCF?
So now, how we find the GCF is those numbers that we wrote in blue there. That's our key. Our GCF is going to be the product of those two to give us 6. So the numbers that we divide by here, in the end, we multiply them together to get our GCF. Here it was 2 times 4 to get 8. Here it was 2 times 3 times 2 to get 12. And now here it's 2 times 3 to get 6. Okay? Questions on this? Who likes the listing method? Is the standard listing method better? Who likes, I don't even know what to call this yet, better? Who loves them both because, oh, thank you, Liam. Thank you, Cade. Oh, yes.
Wasn't there like that? Okay, in second grade, we did like this thing. There was like a mountain. And it was like the falling.
Sounds fun.
And like the falling boulders hit the ants. I hate
The ants?
Yeah.
Sounds violent.
And it was like this.
Oh, I don't know. I was not there in second grade. Yeah.
It was fun.
Yeah. Yeah. When you were in second grade, I still only had one kid. That's how long ago that was. I have 3 with a 4th coming in February, probably January actually. But so yeah.
Wait, what's your oldest?
She's in second grade here, and then middle one is in kindergarten, and then a 2.5-year-old, and one on the way. Yeah. Kate. Shh. Kate asked about method 2, the prime factorization. I'm not going to show you that one. I'm showing you this one instead. So you can kind of cross that one out. And this is your alternate method here. And the reason why I'm not doing prime factorization and this one instead is because this is going to come back. Right? Just like the Sith. This is going to come back. Revenge of the Sith. Yeah, it's kind of a Star Wars thing. Yeah. Sorry, I tried. Yeah, okay. Your homework for Monday, just page 10. Okay? All of page 10, but only page 10. Don't cross out page 11 because we'll do that together on Monday. But your homework for Monday, just page 10. Okay? For Monday. Tomorrow's a retake day. So just page 10. Thank you. Any questions, comments, concerns, complaints, comments, congratulations, or criticisms? Yes, Jeffrey. The goodest. Thank you. Cabe. Yes. Thank you, Cade, for the thought. It's a thought that counts. John. On. Thank you. Congratulations for learning. Jeffrey. Well, I did a little bit of research and I found there's already some math-related, not math dedicated, but math-related ASMR channels. So I have to kind of think about what my niche is going to be. How am I going to be different than what's already there? I don't know. It's a work in progress. All right, that is How You Math.